The notes for lesson 5 will cover the VSEPR theory and Lewis structures. So in this section, you will get step-by-step instructions on how to draw the Lewis structures, and then you will also get instructions on how to determine the shape based on your drawing and how many bonded and lone pairs of electrons you have. So in your green notes packet, this will be on page 6, covering section 8.3. And then, of course, just like always, you will want your yellow periodic table packet. So make sure you have those 2 resources ready to go. If not, pause the video so you can grab them. Otherwise, here we go. So the VSEPR theory represents or stands for valence shell electron pair repulsion. So basically what that means is we know that electrons are negative. We know that 2 negative charges are going to repel each other. So the electrons, whether they're bonded or lone pairs of electrons that are not bonded, those electrons are going to repel each other. So when you have electrons that are repelling, they are going to repel to be as far apart as possible. So the VSEPR theory is what is going to be used to determine the shape of the molecules. So the VSEPR theory states that all bonded electrons and lone electrons will repel each other to be as far apart from each other as possible. You guys will use one of the online simulations to build some of these molecules, and as soon as you add either a single bond or a double bond or lone pairs of electrons, you will see the molecule change shape to adjust for those extra electrons and this VSEPR theory. And also, lone pairs, in addition to bonded electrons, will repel to adjust to the bond angle and shape. So both bonded electrons and lone pairs of electrons will repel to adjust the shape. So for Lewis structures, the steps that I will give you and we'll go through are more of a trial and error process. So once you get to the end and you're checking, there's 2 things for you to check. When you're doing that, you may have to adjust the molecule and adjust your drawing and add a double bond and change up some electrons. So sometimes it gets a little messy. If you don't like the trial and error method, there is another way that I will show you, which is called the need, have, share. So it's more of a calculation up front, but then the drawing is a little easier to complete. So whichever method works for you is fine. So this is the trial and error method. We'll write down the steps and then we'll use it in an example for your in-class practice underneath. So step 1, you will determine the central atom and place all other atoms around it. Step 2, you calculate the total number of valence electrons in the compound. Step 3, you're going to place a single bond between the central atom and all the other atoms. So in your structures, all atoms will be bonded to the central atom at least once. Now 4 and 5 is where it gets a little messy. Step 4, you are going to add electrons around each atom so that all atoms either have or share a total of 8 valence electrons. The only exception is hydrogen. Hydrogen is in hydrogen is in energy level 1 of the periodic table. And in energy level 1, there are only 2 electrons, so hydrogen can only have or share 2 electrons. So that is the one exception you have to worry about. All right, step 5 gives us our 2 questions that we need to ask to double check and make sure that the structure is correct. If both answers are yes, you are done and it's correct and you move on. If one of those answers is no, then you have to readjust your structure and kind of repeat step 4 and 5. So one question that you need to ask is, do all atoms have or share 8 valence electrons? The second question is, does the number of electrons in your drawing match your calculated value of valence electrons, which you did in step 2? So again, both of those questions have to be a yes answer in order for your structure to be correct. If one of them is a no, then you have to go back and fix your structure and double check again. So that's where it gets a little messy. All right, so underneath in your in-class practice, I'm going to do 3 examples with the trial and error method, walking through those steps. And then I will do a separate 3 with the second method, the need, have, share method. So if you don't have room for all 6 in your notes packet, you can put some on a separate sheet of paper. But again, you figure out which method works best for you because they will both work as long as you follow the steps. So here we go with the trial and error method. So the examples that we'll do, I'm going to make this a full screen so you can see a little better, is HCl, I2O, and SO3. So those are the 3 structures that we'll draw. So step 1 is determine the central atom and place all other atoms around it. So the first example, HCl, we only have 2 atoms. So there can't really be a central atom. If you only have 2 atoms in the compound, then you just put those atoms side by side and you don't really even have a central atom. So we'll put hydrogen here and then across from it, we'll put chloride. So that's our first step. Second step is we need to calculate the total number of valence electrons. So I'm going to make a little note for valence electrons. If you look on the periodic table, find your valence electrons for hydrogen and chlorine.
Testing, testing.
They're doing lots of testing with the sound system. Okay, so hydrogen has 1 valence electron. Chlorine has 7 valence electrons. So when you add those up, we have a total number of 8 valence electrons. So that's step 2. Step 3, we're going to place a single bond from the central atom to all other atoms. So again, there's not really a central atom, but if these are a molecule, a compound, they have to be connected by a bond. So we're just going to put a single bond. I usually just draw a line like this, and I know that that line represents 2 electrons. Sometimes people like to put both electrons on each side just to remember them, just to remind them that that single bond represents 2 electrons. So again, either way is fine. All right, step 4 is you are going to add electrons around all atoms so that each atom has or shares 8 electrons. Hydrogen is our exception. Hydrogen can only have 2 electrons. If we circle around hydrogen, it's sharing these 2. So these 2 get counted for hydrogen. So hydrogen is done. It cannot have or share any extra electrons. Chlorine can have 8. So these 2 also get counted for chlorine, so that would be 2. So now we're going to add 3, 4, 5, 6, 7, 8. So you just add those extra dots in step 4 so that all atoms have or share 8 electrons, with the exception of hydrogen. Okay, so now we've done steps 1 through 4. Now you can check. So first question, do all atoms have or share 8 valence electrons, except hydrogen? Hydrogen has its 2, so it's good. Chlorine has 2, 3, 4, 5, 6, 7, 8, so it's good. So the first question is yes. Second question, does the number of electrons in the drawing match our calculated value? So when you count all of these up, each dot represents 1 electron. Each line represents 2 electrons. So this would be a single bond representing 2 electrons, 3, 4, 5, 6, 7, 8. My drawing has 8 valence electrons. I calculated that I needed 8 valence electrons. So both those answers for step 5 are a yes. So I'm done. My structure is correct and I know it's done. All right, second example, I2O. So with our central atom, the central atom is usually elements that are in either groups 4, 5, sometimes 6. Usually it is the element that has the least number of atoms. Like this has 1 oxygen atom compared to 2 iodine atoms. So those are kind of 2 ways that you can figure out the central atom. If carbon is in the compound, carbon will be your central atom. Carbon is in group 4. So group 4, 5, sometimes 6, or the least number of atoms in the formula. So oxygen will be our central atom. And then, whoops, not fluorine, iodine, sorry. We have 2 iodines, so we're going to draw iodine on each side. So step 1, we figure out our central atom. We place all other atoms around it. Step 2 is we calculate the total number of valence electrons. So iodine, if you look on the periodic table, I want you guys to pause the video for a second, check out your valence electrons, and then we'll unpause and resume. All right, hopefully you paused. Iodine is in group 7. So iodine has 7 valence electrons, but how many iodines do we have? There are 2 iodines, so we have to take 7 times 2 plus oxygen. If you look on the periodic table, oxygen has 6. So 7 times 2 is 14, plus 6 more is 20. So we have to account for 20 total electrons in our drawing. All right, step 3, place a single bond from the central atom to all the other atoms. So I'm going to put a single bond here and a single bond here. Again, you won't ever have any that are enclosed or like a circular or triangular shape. They will all have a central atom with atoms or elements breaking off at that. So now in step 4, we're going to add electrons so that all atoms have or share 8. So again, this counts as 2. So for iodine, iodine would have 2, 3, 4, 5, 6, 7, 8. Oxygen is sharing 2 here and 2 more here. So oxygen would share 4 right now. So we're going to add 5, 6, 7, 8. Iodine is sharing 2. So then we count 3, 4, 5, 6, 7, 8. So that would be step 4. Now step 5 is what we need to check. So 2 questions in step 5. Do all atoms have or share 8 valence electrons? So iodine has 2, 3, 4, 5, 6, 7, 8. So iodine is good. Oxygen has 2, 4, 5, 6, 7, 8. So it's good. This iodine has 2, 3, 4, 5, 6, 7, 8. So it's good. So the first question is a yes. The second question, does the number of electrons in my drawing match my calculated value? So now if I count all of them, I'll start over here with iodine. Here's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So if they match, you're done and you're good. All right, last one with our trial and error. As you can imagine, this one won't be as simple. SO3. So same thing, step 1, determine the central atom and place all other atoms around it. Sulfur will be our central atom. It is in group 6, and also it has fewer atoms than oxygen in this case. So I'm going to put sulfur in the middle. I'm going to put the oxygens around it, like so. Adjust this so you can see a little better. Okay, so step 1 is done. Step 2, we calculate the total number of valence electrons. So sulfur has 6 valence electrons. Each oxygen has 6 valence electrons, and we have 3 oxygens. So we're going to take 6 times 3 for 18, plus 6 more is 24 valence electrons that this drawing has to account for. All right, step 3, place a single bond from the central atom to all connected atoms. Step 4, we're going to add electrons so that each atom has a total of 8. So here's 2, 3, 4, 5, 6, 7, 8. This oxygen is sharing 2, 3, 4, 5, 6, 7, 8.
Hello, Adam, in the Activity Center. Can you hear me?
Okay. So sulfur has 2, 4, 6. So I'm going to add 7, 8 on top. Oxygen has 2, 3, 4, 5, 6, 7, 8. So now all my atoms have 8. So now we are at step 5, so now we're going to do our check. 1, do all atoms have 8 electrons? Oxygen has 2, 4, 6, 8. This oxygen has 2, 3, 4, 5, 6, 7, 8. Sulfur, if you circle around sulfur, has 2, 4, 6, 7, 8. This oxygen has 2, 4, 6, 8. So yes, all atoms have 8 electrons. Now we have to check, does the number in the drawing, does the number of electrons in the drawing match my calculated value? So if I count them all up, I'm going to move the camera down so you can see those other two. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So the drawing has 26 electrons. I can only have 24 electrons in the structure. So I have too many electrons. So if one of those questions is a no answer, then you have to go back and adjust and add a double or triple bond. So if we're going to add a double bond, since all 3 of these are oxygen, it doesn't matter where we put our double bond, because here sulfur is bonded to oxygen, here sulfur is bonded to oxygen, and here sulfur is bonded to oxygen. So we can just pick whichever one we want to add in a double bond. So now, because we've added a double bond, now we have to go back and adjust so that all atoms have 8 electrons. So now oxygen has 2, 4, 6, 8, 10. So I'm going to take these 2 electrons and I'm going to get rid of them, because now instead of oxygen and sulfur having separate electrons, now they're going to be sharing 2 extra. So now this oxygen is fine. Sulfur is sharing 2, 4, 6, 8, 10. So I'm going to get rid of these, because now sulfur with that double bond would have a total of 8. So this sulfur is good. This right side oxygen is good. The bottom oxygen has 2, 3, 4, 5, 6, 7, 8. So it's good. This left side oxygen has 2, 3, 4, 5, 6, 7, 8. So it's good. So now for step 5, we've double checked so that all atoms have 8 valence electrons. Now we have to ask our second question, does the number of electrons in the drawing match our calculated value? So now in the drawing we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We're good. So because this structure, because those 2 answers didn't check off right away, then we had to readjust it. So that's where trial and error gets a little messy, but you have to go back and check both of those answers to see if they are, if both of them are correct before you move on. So that's one method. The second method is written here. It's called the need, have, share. Again, as long as you know how to do one of these processes, you will be good to go. So I'm going to erase these and add these new examples up. Okay, so need, have, share. A little more work is up front, but then your drawing is a little easier as to if you need a double or triple bond. So the first example is N2. So we have 2 nitrogens. We're just going to draw 2 right beside each other. So step 1, find the central atom, is pretty much the same as the previous steps. So since we only have 2 atoms, we won't really have a central atom. Step 2, you're going to set up your calculation. So I am going to go full screen again so you can see my calculation. I'll switch colors here. So for my calculation, I do NHS. So this is need, this is have, and this is share. So here's how you calculate need, have, share. The need is how many electrons each atom needs to be stable. So all atoms want a stable octet. So all atoms need 8 electrons to be stable, with the exception of hydrogen. Hydrogen only needs 2 electrons to be stable. So this nitrogen would need 8, and this nitrogen would need 8 electrons. So that's where we get our total of 16 for the need. The have is what you previously did in step 2. You just look on the periodic table, figure out how many valence electrons there are, and add them up. So nitrogen is in group 5. So each nitrogen has 5 valence electrons. So we have a total of 10. When you subtract these, that determines how many electrons that structure will share. So this structure is going to share 6 electrons. Remember, each bond represents 2 electrons. So when you divide that by 2, that tells you how many bonds are going to be shared between those 2 atoms. So you can either remember that you have 6 electrons or 3 bonds to share. We only have 2 atoms, so all 3 bonds have to be between these 2 atoms. So I'm going to add 1 bond here, 2nd bond here, 3rd bond here. Here would be 2 electrons shared, here would be 4 electrons shared, and here would be 6 electrons shared. So you can view it as how many electrons are shared, or divide it in half to get how many bonds are shared. So this is a little cleaner for the drawing. However, you still have to go back and add extra electrons in so that all atoms have a total of 8. Nitrogen right now is sharing 6, so I'm going to add 7, 8. This nitrogen is also sharing these 6 electrons, so I have to add 2 more over here. So that would be your structure for N2. All right, CO2 and H2S. Sorry, I forgot the other 2 examples. All right, so these are the second 2 that I'll show you with the need have share. Oops, I might move this one up a little bit. All right, so CO2, carbon is going to be our central atom. If carbon is in the compound, it will always be in the middle. So I'm going to put carbon on each side, or on one side, and put each oxygen around it. All right, I'm going to erase this so I have more space. So I'm going to do need, have, share. Okay, so each atom needs 8 to be stable. So oxygen needs 8, carbon needs 8, oxygen needs 8. So you have 3 compounds that need 8 electrons total. So we need a total of 24 electrons. The have is how many valence electrons that element actually has when you look on the periodic table. So carbon has 4 valence electrons, each oxygen has 6, and you have 2 oxygen atoms, so 12 plus 4 is 16. So when you subtract them, we know that we have to share, the structure is going to share 8 electrons, which would then be 4 bonds, because a single bond represents 2 electrons, so that's why we have to cut it in half to find the number of bonds. So in this structure, we're going to share a total of 8 electrons, or 4 bonds. So if we have 1 here, the second one here, now we're going to just start adding double bonds, because these are the only places that we are able to add them. So this would be our 3rd bond, this would be our 4th bond. So 2, 4, 6, 8. There are those 8 shared electrons between the structure. And then once we have all of those electrons, we have to go back and add extra electrons so that each atom has 8. So oxygen is sharing 4, so we're going to add 5, 6, 7, 8. Carbon is sharing 2, 4, 6, 8, so carbon is good. This oxygen is sharing 2, 4, 5, 6, 7, 8. So we're going to add in those extra electrons, and you're done. So again, a little more work on the front end, but then your drawing is a little easier to determine if there's a single bond or a double bond. All right, last example is H2S. So hydrogen will never, ever, ever be your central atom. So sulfur will be our central atom. Hydrogen can only ever bond once or share 1 single bond. So that's why it will never be a central atom, because it can't branch off to several different atoms. It can only bond once. So we have H2S. We have to do our need have share. So here's where it gets a little tricky because hydrogen is an exception. This hydrogen needs 2 electrons to be stable because in order for hydrogen to look like a noble gas, it's going to look like helium, which only has 2 electrons. So this hydrogen needs 2. This hydrogen needs 2. So that's 4. This sulfur needs 8. So total, we would need a total of 12 electrons. Now for half, we count out how much we actually have from the periodic table. Hydrogen has 1 valence electron, and we have 2 hydrogen atoms. So we take 1 times 2, plus sulfur has 6 valence electrons. So we have a total of 8 electrons. So if we take 12 minus 8, oops, we get 4. And then that would be 4 electrons, which would represent 2 bonds, because each bond represents 2 electrons. So we know for this whole structure, we're only going to share 2 bonds. Here's one, here's the second one, because every atom has to connect to the central atom at least once. So if we have 2 bonds to share, we know that we have to distribute them between those 2 hydrogens. So once we have those 2 bonds in place, then we can circle around. Hydrogen can only share 2. So once it's single bonded, then it's done. Sulfur is sharing 2, 4. So we would add 5, 6, 7, 8. Hydrogen is sharing these 2 from the single bond, so it's good. So this is what the structure for H2S would look like. So either method is fine. Sometimes, people start with the trial and error method and then move to this one if that one doesn't work. So it's just whatever works for you.